everyone, and welcome to this week's chemistry lessons. Today we're going to learn about the evidence of climate change. This week, you're going to learn about and you're going to discover how ice cores can be used to reconstruct a picture of past changes in Earth's climate, investigate the relationship between past sea levels and average global temperatures, discover how living organisms such as coral reefs and trees can be used to make inferences about climate trends, and you're going to learn how to investigate how natural phenomena can contribute to climate change. Ice cores and ice ages. In lesson 1, we're going to learn all about ice cores. First, we're going to learn about glacier ice. You can see in the picture, there is a piece of glacier ice. So glacier ice forms from the compaction of snow year after year, building up a record of climate that extends back millions of years. Now, we can learn a lot from the ice, from the core of the ice. So the isotopes in the ice provide clues about temperature. The heavy isotopes, oxygen-18 and hydrogen-2, or deuterium, are less abundant when temperatures are cold. So when temperatures are colder, we're going to see less of those isotopes. So we can measure the amount of isotopes in the ice and use that information to tell us how warm or cool was it when that snow fell. Ice core analysis reveals a repeating pattern of long, cold ice ages separated by brief warm periods called interglacials. This 100,000-year-long cycle is largely a result of oscillations in the elliptical shape of Earth's orbit around the sun. So the Earth actually isn't a perfect sphere. It's not a perfect circle. It's an elliptical. So it's kind of a little, not exactly football shape, but just a little bit less perfectly round. So ice cores are really interesting. In some cases, ice cores have been shaved into slices about 120 micrometers thick, which is really, really small. So it's a really small sliver of ice. And you can actually figure out the monthly temperature, the pollen, and volcanic ash changes within that time period. So it's really interesting because looking at the pollen, we can figure out what kind of plants were growing at that time. And did a volcano erupt? So it's pretty interesting what we can learn by looking at that. Okay, so we're going to look at ice cores and what we can learn about them. So we're going to look at this chart, and then I'm going to show you a website that has some really interesting information about ice cores. So ice cores from Antarctica and Greenland tell us a lot about the past of our planet's atmosphere and climate. And why Antarctica and Greenland? That's because that ice has been around the longest. And because they're the coldest places on the planet, so that ice hasn't really melted for a really long time. But if we're looking at ice in other parts of the planet, it melts on a more regular basis, so we can't go back as far in time. So we can look at drilling ice cores. They use a drill to get these ice cores. So most ice cores are drilled in Antarctica and Greenland. The oldest continuous ice core record extends to 130,000 years in Greenland and 800,000 years in Antarctica. That means that we have a record of snowfall for 800,000 years. That's That's a lot. So Antarctica has been cold and snowy for a really long time. The deepest ice cores are about 3 kilometers or 2 miles deep. That's a lot of ice. It's a lot of ice. Okay, so let's look at the drill. So it has an anti-torque part. It prevents the drill from rotating in the hole because you don't want to melt the ice when you're drilling out the ice. That would be bad. Then you really don't have any data to work with if you just have a puddle of water. We have the CHIPS chamber, the pump. It transports drilling fluid and the ice chips to the CHIPS chamber above the drill head. The motor spins the drill head in the core barrel, and the core barrel holds the drilled ice core and moves ice chips away from the drill head. So the cores are drilled and brought to the surface, typically in 4-meter sections. And then you can kind of place the sections together. The ice cuttings are collected to keep the borehole clear, and an ester-based drilling fluid is pumped into the hole to stop the ice pressure from collapsing it. So they're using some chemistry, some chemicals to help prevent the sides of the part they drilled from collapsing. So interesting things we can see in ice. So do you see the layers? So the layers, if you look at the middle section, they're telling us things about this ice. So we can look at summer layers and winter layers. Cores can be dated visually by counting the layers or by using electrical conductivity measurements. Variations in snowfall density give lighter layers for summer snowfall and darker layers in the winter. So we can see just visually the layers. So the light layers are summer and the darker layers are winter. Variations in summer and winter snowfall acidity affect the electrical conductivity of the ice. So we can see where there's like a darker regions, that's a lot of heavy snowfall, and maybe we have more like light regions, so maybe it's less snowfall. Isotopes can also be used to date ice cores and gauge the temperature at the time of snowfall. Water molecules containing the heavier isotopes don't evaporate as easily as water molecules with the lighter isotopes. Therefore, the ratio of isotopes in ice core layers links to the temperature at the time. Higher temperatures are indicated by heavier isotopes. So because they're heavier, there's less evaporation. So they're going to kind of stick around. And higher temperatures, there's more evaporation. Okay, we can also look at carbon dioxide and pollution in ice cores. So it's not just looking at the composition of the water that makes up ice, there's other stuff in it too. Carbon dioxide concentration in the atmosphere can be obtained from gas chromatography of ice core samples. Ice core records from the past 800,000 years show pre-industrial levels of carbon dioxide, and we can see that they never reached higher than 300 parts per million. This year, we reached 412 parts per million. This was in 2017 when this graphic was published, so it's 3 years old, but it's still pretty close. So 300 parts per million in 2017. In 2017, we reached 412 parts per million. Records of carbon dioxide concentration correlate with ice core temperature records. Now, another thing we could look at is volcanic activity, which is really interesting. So yearly levels of other substances in the atmosphere can also be determined from ice cores. Sulfate ion peaks in ice core layers result from volcanic eruptions. They also increased due to the burning of fossil fuels, but slightly decreased in recent years due to the clean air legislation, which is great. Atmospheric lead levels due to industry, and leaded petrol can also be tracked. And petrol is the European word for gasoline. Next, I'm going to take you to a website on ice cores, and we're just going to look a little bit more about the chemistry and science of ice cores. Okay, so we're going to look at the science of ice cores. They are atmospheric time machines. This was published August 15, 2017, so it's not that old. And this is where I got the graphic from. That was very informative. Okay, so we're just gonna briefly go through this because there's some really nice pictures in here to show you how scientists work with ice cores. So this ice core is 1 meter long, and it contains ice which fell in snow between 1489 and 1493. Oh, what happened then? Well, I remember the old saying, 1492, Columbus sailed the ocean blue. So just around when Columbus was sailing the ocean, this snow fell somewhere. So this core was pulled up from 149 meters below the surface of the ice. An interesting thing is ice core analysis isn't something that's been around forever. It didn't even get serious traction until the 1950s when the first ice cores were drilled. So there's so many ice cores we have not drilled yet, and so much we can learn from studying ice cores because it hasn't been done for that long. And we have better drills now that can dig deeper and deeper to get older and older ice cores. Okay, so we can look at some data. We can look at the carbon dioxide concentration in parts per million and how it's changed throughout time. And there's just a lot of things you can learn about by looking at ice cores. Okay, so I hope you learned a thing or two about ice cores. They're very interesting. They can tell us a lot. We can learn about the temperature of the earth, how much carbon dioxide there was, different things inside of the ice like pollen and pollution, and different chemicals can tell us if volcanoes erupted. So ice cores, they tell us a lot about the history of Earth's climate.